Hi guys, today let's discuss the LeetCode question 236, lowest common ancestor of a binary tree. Given a binary tree, find the lowest common ancestor of two given nodes in the tree. According to the definition of LCA and Wikipedia, the lowest common ancestor is defined between two nodes P and Q as the lowest node in the tree that has both P and Q as descendants, where we allow a node to be a descendant of itself. Let's go to the example 1. So if we go to the example 1, the two nodes in the question are P equal to 5 and Q equal to 1, P equal to 5 and Q equal to 1. So the lowest common ancestor in this case is going to be 3. This is the lowest common ancestor. Let's go to the example 2. So in this example, P is equal to 5 and Q equal to 4. So P is equal to 5 and Q equal to 4. So in this case, the lowest common ancestor is going to be 5, because a node can be a descendant of itself. That is the reason we can choose 5 as the lowest common ancestor. Let's go to the example 3. So in this example 3, there are two nodes, 1 and 2. So out of which 1 is the lowest common ancestor, because when we have only two nodes, then the root node is going to be the lowest common ancestor. Yeah. So let's go to the constraint section as well. So the minimum number of nodes in the tree is going to be 2, and the maximum number of nodes is going to be 10 to the power of 5, and all the node values are unique, because if the node values are not unique, then we cannot find that LCA, lowest common ancestor, for that given tree. And P naught is equal to Q. So P and Q are two different nodes in the tree, and P and Q will exist in the tree. So which means that there is no case where P and Q doesn't exist in the tree. Okay, I think it is quite clear from the question description. So, let's go into the explanation part of it. Let's start our explanation by considering these three cases. If we look at the case 1, P and Q exist in the left subtree and right subtree of the given tree. So in this case, it is going to be our P and Q exists in the left subtree and the other exists in the right subtree. Let's go to the case 2. In the case 2, my P and Q values, P or Q, equal to root, and the other exists in the right subtree. So it exists. So this is my node in the question. My node in the question is 5. So my P or Q equal to root, and the other node exists in the right subtree. So in this case, the lowest common ancestor is going to be 5 in the case 2. Let's go to the case 3. If we go to the case 3, then my P or Q equal to root, comma, and the other node exists in the left subtree of the given tree. So in this case, it is going to be P or Q equal to root and the left. So for all, if we consider all these three cases, if we wanted to arrive at a formula that we can use for all these three cases, then it is going to be like this. So my LCA node is going to be a node which satisfies all these three conditions. So one is, it should be left plus right plus P equal to root, or Q equal to root. And this is going to be equal to 2. So if any of the nodes satisfies this condition, the left, if the P or Q exists in the left subtree or the right subtree, or P equal to root or Q equal to root, for any node, if this sum is equal to 2, then we say that particular node is a LCA node, is the lowest common ancestor node for the two nodes given, P and Q. So let's apply this formula for all the three cases that we have discussed so far. So if we go to the example case 1, so in this case, P and Q exist in the left subtree and the right subtree. So the value of L plus R in this case is going to be 1 plus 1. So we are arriving at a value equal to 2 for the case 1. So let's go to the case 2. In the case 2, P or Q equal to root and the other P or Q value exists in the right subtree. So in this case, my P or Q, we are getting a value of 1 here and the right value is 1. So 1 plus 1 is equal to 2. Let's go to the case 3. Even in the case 3, P or Q equal to root. So this value is going to be 1 and followed by the left subtree value is going to be 1. So which means that other P or Q value exists in the left subtree. So the value is equal to 2. So for any node, if it satisfies this condition, left plus right plus P equal to root or Q equal to root equals 2, then we say that node is a lowest common ancestor node. So finally we have to return this node. Yeah, I hope it is clear from this explanation. Let's quickly code this up. Let's start by creating an LCA node variable. So this is going to store my lowest common ancestor node that we are going to return. So my LCA node, initially we are going to initialize this one as none. Then we are going to create a temporary function for the recursive calls. So we are going to name it as LCA of root. If root is none, so which means the root is none and we did not find any of the P or Q, then we are going to return false in this case. Else, then we are going to recurse towards the left first, LCA of root dot left, and we are going to recurse on the right as well, LCA of root dot right. After this, we are going to find our lowest common ancestor node, and if as explained in the explanation part, if we find this sum equals to 2 when P equal to root or Q equal to root plus left plus right. When this sum is equal to 2, then we are going to update this LCA node. So my LCA node is going to be root. And finally, what we are going to return? We are going to return true if any of the condition is satisfied when P equals to root or Q equal to root or left, if it is found in the left subtree or if it is found in the right subtree, then we are going to return true. Finally, we should be calling this LCA temporary function, LCA on root, and finally we are going to return LCA node, that is the lowest common ancestor node that we found. I hope we are done. Let's quickly run the code. We got an error. We are getting it as null, LCA node. Okay, yeah, we should define this LCA node as non-local because we are defining it outside the scope of this temporary function. That's why we have to define it as non-local. So non-local of LCA node. Let's quickly run the code as well. Yeah, it is accepted. Let's quickly submit it as well. Yes, it is submitted. Hope you liked the explanation. For more such videos, please subscribe to my channel. Thank you.